What's going on, guys? Today we'll be going over a quick comparison between the linear isotropic material model and plasticity material model in SolidWorks simulation. I have set up a simulation with a bracket made from 6061 T6 aluminum. The bracket is fixed where the green arrows are, and the load location and direction is shown by the purple arrows. For this comparison, we will be taking a look at the max stress, max displacement, and factor of safety. The first analysis has the linear isotropic material model. And has a static load of 875 kilograms. The max stress is 507 megapascals. The max displacement is 4 millimeters. And the factor of safety is 0.5. The second analysis has the plasticity material model with everything else the same as the first analysis. The max stress is 276 megapascals. The max displacement is 4 millimeters. And the factor of safety is 1. By comparing the max stress and factor of safety between these two similar analyses, we can see there's a big difference. On the first analysis, we got a max stress of 507 megapascal and a factor of safety of 0.5, while on the second analysis, we got a max stress of 276 megapascal and a factor of safety of 1. What's happening is, on the linear isotropic material model, which is the first analysis, the material behaves elastically forever, no matter how high the stress gets, basically ignoring yielding, which is the point where the material starts to deform permanently. In simpler terms, when the load gets high, the software just keeps increasing the stress value as if the material could take it. On the other hand, the plasticity material model, it includes the yield points and allows for plastic deformation. Once the material reaches the yield stress, it doesn't increase the stress linearly anymore. It deforms plastically, and the stress levels off. So, why is this important? Depending on your application and requirements, plasticity is crucial for accuracy, as the linear isotropic material model overestimates the risk of failure, which could lead you to over-designing or wrongly assuming a part is unsafe. I went a step farther and created a third analysis with a plasticity material model and a dynamic load of 875 kilograms on the same location. So basically, on the analysis, it starts with no load. The load is then applied for an X amount of time, and then it finishes with no load. This way, we can check if there is any permanent deformation on the part after being exposed to the load. Max stress we got was around 276 megapascal, which is identically to what we got on the second analysis with the static load. The displacement at the end, after the load was applied, is 0. As you can see here, you can see how the displacement develops as the load is applied, and then later the load is taken off. The factor of safety of the part is 1, which is the same as what we got on the second analysis. I want to thank you guys for watching the video, and if you need designing or simulation services similar to what you see in my channel, please contact me. My information is in the description of this video. Thanks for watching. Bye now.